This is episode 16 of Soundproofist, and my name is Carrie. Recently, we were contacted by an interesting startup in Austria called 7Bell. They've designed a new device that measures noise, but it's more than just a decibel reader. It's a visual acoustic camera that scans and analyzes sound frequencies, and it works with your smartphone. According to the information on their website, this device can help to identify the sources of unwanted noise. And it can be used by engineers, say in the automotive industry or in other manufacturing applications, and also large architectural projects. I thought it sounded really interesting, so I invited them to talk about their product with Soundproofist. And I got more details from the founder of 7Bell, Thomas Rittenschober. So, tell us about your product.
At 7Bell, we develop and sell professional sound imaging equipment for visualizing and locating sound emitted from products and processes. The images that you get are very similar to those from thermal imaging cameras. Essentially, it is heat maps overlaid onto images from the product or process you're looking at. So very intuitive in the sense that red-colored areas indicate high level of sound emissions, and blue-colored areas are more or less silent areas. Such sound equipment is typically used by acoustic consultants and engineers from product design, manufacturing, quality control, and also maintenance. In fact, there are many situations when engineers are confronted with noise issues in their products and processes. It may happen that, for instance, a machine tool fails to meet regulatory noise limits, or that a customer relevant noise requirement in the car cabin cannot be met. And especially in such industrial applications where noise emissions typically have low frequency content by nature, the human ear is just not capable of locating noise sources reliably, and it becomes very difficult for engineers to solve such problems efficiently, meaning in a short amount of time and with high confidence, meaning not iterating forever. And this is exactly where we come in. We provide easy to use, mobile, and more or less self-explanatory measurement devices for visualizing sound sources. And by this, we support engineers in making the right choices and decisions when fixing acoustic issues with the products and processes.
Can you describe how it works?
Our equipment consists of a rotating rod with a couple of microphones which are distributed along the rod and scan the sound field emitted from a product or process. The audio data captured by the microphones is sent to the cloud, where the data is processed by a high-performance computer, and the resulting heat maps are sent back to the user's mobile device and overlaid onto the image of your product. From there on, it's all about looking at the images and assessing the sound emissions from your product or process. For example, is there anything unexpected? If yes, why is this the case? Can I resolve the issue by redirecting or dampening the sound emissions? So these are the questions that you would typically ask yourself. And it takes a couple of iterations to shape the sound emissions to the point where you want to have them. Sound scanners are, in such situations, the right tool to help you so that you don't get lost in the complexity of the problem.
How do you use it?
So let us take a typical example from product engineering. A first prototype of a new machine tool is available, and the engineers start making the first verification tests. They observe that the sound pressure level during processing is simply too high, but it's not clear where the problem is. Of course, you hear the processing sound, but the weakness in the design of the construction is not obvious. So you would simply position our sound scanner in front of the machine tool, let us say at a distance of 10 feet or so that you have the entire machine in the image. You then switch on the machine such that the processing sound is happening, and you start rotating our sensor for a couple of revolutions. When you have captured the sound event you're interested in, you just wait a couple of seconds for the result, and then you start analyzing the acoustic images. You try to understand where the sound sources are sitting in the image. You start asking questions around what is the loudest sound source expressed in dBA and where is it? What is the difference between the loudest and the next neighboring sound source? And based on these acoustic images, engineers who perfectly know the design of the product start to make conclusions about what the potential root cause is. It can be, for instance, a leakage in a machine housing. Eventually, the engineer then makes a quick fix and measures the whole situation again. And if the improvement is confirmed, a technical solution for serious production can be developed.
That sounds really useful.
Another interesting application can be found in the field of building acoustics. Sound transmission between rooms is in most cases unwanted and shall be suppressed as much as possible. So let's say we have a meeting room next to an office space. People in the office space sitting close to the meeting room do not want to be disturbed by the maybe heated discussions in the meeting room. And for this reason, acoustic consultants use omnidirectional loudspeakers and tapping machines in a source room to assess sound transmission into a receiving room. And while sound pressure level meters would give you an indication whether transmission is within limits or not, our sound scanners identify weaknesses in the architecture and where the weakness exactly is. So this simply gives you more information to get more quickly to the actual root cause and eventually fix it.
And what tools does a user need to have before they get started?
We ship our sound scanner in a pretty robust case, which includes everything that you need to get rolling. From a hardware point of view, our solution is pretty lightweight in the sense that you just need the sensor mounted onto a tripod and a mobile device along with an internet connection. All of the magic of computing the acoustic images is happening in the cloud, so there is no laptop or data acquisition system involved, and also no hassles with cables and wiring. It's also important to note that you don't need AC power to operate the system, because the sensor and the user's mobile device are both battery powered. For convenience, we have included a power bank to recharge the sensor and the mobile device in situations when you don't have access to a power outlet.
Where has it been used?
During the development phase of our sound scanner, we tried to cover applications from a ton of industries. So we investigated sound emissions from engines, drivetrains, gearboxes of cars, trucks, and motorcycles. We analyzed pass-by sound of trams with flat-spotted wheels. We looked at leakages in HVAC systems in buildings. We tracked down dominant noise sources in an industrial area from a distance of 1 kilometer. So there's a host of applications out there for our product, and it's not necessarily limited to the size of the object or the distance from the object that we're looking at. So the good thing is, as long as you can hear it in an appropriate frequency band, you can localize the sound emissions.
How is it different than using a decibel reader app?
The difference can be explained quite simply. Let's say you have an issue with a product or process in the sense that something is too loud. A calibrated sound pressure level meter would give you the confirmation that yes, there is something too loud, but what will you do then? And this is exactly where the sound scanner steps in and shows you exactly where the dominant sound source is sitting. And this information has a totally different quality in the sense that your confidence becomes much higher in making the right decisions when it comes to implementing the technical solution to your acoustic issue.
What kind of reports can it create?
Using our mobile app, you can export a PDF report of the currently selected acoustic image. And this report states all of the relevant pieces of information associated with the image. For instance, who made the recording, when was the image recorded, what is the maximum sound pressure level in the image, how does the associated frequency spectrum look like, and so on and so forth. So the report more or less meets what you would typically expect from a quality management type of document. And on top of that, you can also easily archive and import your measurement records for later use. And this is exactly the area where we leverage several convenience functions that come with today's mobile operating systems.
Do you run it over time? 24 hours a day, or only for brief readings?
For now, our sound scanners are targeted at applications where users want to quickly analyze sound issues with a product or process. So this typically only requires a couple of seconds of sound recordings. But for the future, this is certainly something that we may want to look into.
We've basically covered this already, but can you identify the typical applications for this instrument?
The field of applications is super wide for our sound scanners, and there's not really a best use application. I would say we currently see a lot of traction in industries which are exposed to meeting harsh regulatory requirements. Specifically, this is machinery construction, automotive, transportation, power, and also building acoustics.
What's the cost range?
We have just started introducing our sound scanners on the European market, and prices range from 5,500 euros to 15,800 euros. This, of course, depends on features and sensor size.
Where can customers get your products?
Our sound scanners can be purchased directly from us, so people interested in our products are invited to go to our website www.7bell.com to learn more about our products and to contact us for a quote. At this stage, we're really happy to learn more about potential applications from our customers, and we are also committed to giving our customers honest feedback on whether our sound scanners are suited for a specific application, and if yes, which sensor model we would recommend.
I'd like to thank Thomas Rittenschober for sharing information with us here on Soundproofist. If you're curious to know more about this tool, visit their website at 7bell.com. That's SEVENBEL.com. Their site is in German and in English. Thanks for listening.